Hello and welcome to this session on inheritance. In object-oriented programming, the idea of inheritance is a very important and key concept. The general idea is that you will have a parent or a base class which contains attributes that are common to all other types of that particular class. And you will have child or subclasses which have unique attributes and perhaps even unique methods that are specific to that type of class, of subclass. In the example at the top on the right, you can see we have a base class called network device. And as you look at the code below, you can see that network device has general data that is common to all different types of devices, such as IP address, username, and password, as well as some general methods. You will have subclasses for each specific type of network device that you want to create. In the example, we show an iOS device and an XR device. If you look at the code, there will be iOS-specific data and iOS-specific methods for the iOS subclass, and the same is true for the XR subclass. One of the key ideas related to inheritance is the opportunity for child classes to override methods that have been defined in the base class. If you look at the diagram, you can see that network device has a method defined as getInterfaces. However, iOS device has its own definition of getInterfaces, which is specific to how you would get interface information from an iOS device. In the example, it is shown using SSH in order to get this information. For an XR device, which happens to support netconf, the operation and method of performing getInterfaces could be done using something such as netconf. And so getting interfaces will be different for the XR device as opposed to the iOS device. A caller using this type of object can call getInterfaces, and it will return the interface values, but the actual methods inside the device subclass that was used to get the information is unique to that particular subclass. Hello and welcome to our demonstration of inheritance in object-oriented programming. Specifically, we will be showing you inheritance when you create network device objects. For this exercise, we're going to be using the devices file as we have before. It's important to notice in this devices file, it's pretty similar to what we've had before. We have a couple of iOS devices, we have a couple of NXOS devices, a couple of XR devices, a couple of XE devices as well. So this is information that we will be using as we go through the process of creating our objects. Now, as I mentioned, we're going to be demonstrating inheritance. And since we're demonstrating inheritance, you will expect to see the following. First, we've defined our base class, which is called networking device or network device. And this is very similar to what we've had before with the initialization of setting the name, IP address, username, and password. Now you can see that we've also created an OS type, and we're setting that to unknown. In the base class, we don't know the specific OS type. But what we're going to do is we are going to create a subclass called network device iOS, and we're going to create another subtype called network device XR. And these are both going to inherit from network device. So you see in the parentheses, we're referencing the fact that these are inheriting from network device. What that means is everything you see here in network device is going to be part of network device iOS. So network device iOS will have a name. It will have an IP address, a username, password, and OS type. So, and that will be true for XR devices as well. So we've only defined two different subclasses. We have not defined NX devices and we haven't defined XE devices. We'll see why in a minute, because the main reason being that we're not going to use those. One thing to notice is that we're going to call the initialization function when we get a device of this type created. So we are going to pass in the name, the IP address, username, and password. And we're also going to set the OS type to the appropriate OS type for this device. If somebody creates a network device iOS, then we're going to set the device type or the OS type to iOS, and the same is true for iOS XR. When we read in the information from this file, this is an important function to understand. We've made it a little bit deeper and richer in terms of what it's going to do. You're familiar with this. We open the file, we read in our devices file, and then we take the information from the line that we just read in, and we are going to put that information into our device info, which is a list of information about this particular device. Now we're going to look at the second item, which is actually item sub 1 in the list, and we're going to check to see what the OS type is, because if you recall, the second item in each of these lines is actually the OS type. From here, based on the OS type, we're going to create either a network device iOS or we're going to create a network device XR. Now we'll see later why this is really important. Communicating with an iOS device may require different functionality. The CLI may be different, or maybe we'll use one protocol when communicating with iOS devices and a different one, such as netconf, when communicating with XR devices. So this can be a very important distinction, but they are both network devices, and they all have names, IP addresses, usernames, passwords, etc. If the device is neither of these, we're going to just say we're not going to create anything, so we're going to ignore those devices for now. We close the file at the end. You are familiar with our print device info function, where we are just going to be passed a list of devices, and we are going to print them out. And down here in the main functionality, all we're going to do is we're going to say read device info from this file called devices, which we've shown you. And then we're going to print device info from devices. And we're going to be printing out the name of the device as well as the OS type. This is referencing our object called device. Remember that we're getting this device object, and the device object will be either a network device iOS type or it will be network device XR. But because they share all of these attributes that we have set appropriately when we created them, we're able to use the same attribute names in order to print this out, independent of whether it's an iOS device or an XR device. What does this look like when we run the application? When we run the application, we will see that it is going to print out, notice, only 4 devices. Remember that we were looking only for iOS devices and for XR devices. And so what we ended up doing, these are representing the objects that were network device XR. These are representing the objects that were network device iOS. We used the same print functionality to print all of them out, and we used inheritance in order to share common attributes between the base class and the subclasses. So this is the way that you would create network device objects and use them in Python. Hello and welcome to our session on overriding methods in Python with our network device objects. Once again, we're using our devices file. The code for this application is very similar to the code that we described when we went through the inheritance example, but there's a couple of differences. In our base class network device, we are defining a method called getType, which will return the type of operating system. And in this particular situation for our base class, we're going to return the word base because there really isn't any special device operating system type for this device because it's just the base class. Within network device iOS, we're going to override getType from the base class, and we are going to provide our own, which will return the value iOS. For network device XR, we're going to do the same thing. We're going to override getType, and we will be returning iOS XR in this situation. Our read device info is pretty much the same as it was before, except for one difference. We're actually creating a base class if we don't find that the operating system type is XR or iOS. So we create a base version of this. We append it to the list. Here is our print function, and in our print function, there's one difference. That is, when we print out the OS type, we are going to call this method called getType. So be aware that this device object, it may be a base class, it may be an iOS device type of object, it may be an XR type of object. So it could be any of those. We're calling the same function. This is one of the reasons that object-oriented programming is so nice. I can call the same function. I don't have to know exactly what the type of object is because they all support getType, and they've overridden it, and they will return the appropriate value. The main application is exactly the same as it was before. I'm reading the device info, and then I'm printing device info. What this looks like when we print it out is as follows. Remember, we are creating device objects for every single device this time, not only a couple of them. You can see for the ones that are iOS, we're returning the value iOS. Remember, we did a getType, and we called getType, and when we defined getType in our classes, you can see that we're returning the string iOS, iOS XR, or base. So this is what is getting returned by the call to getType that you see right here. And looking again at the output, we can see that we either get iOS if it happened to have been an object that was an iOS device, base if it was one that we did not create a specific type, so we just created the base class, or iOS XR for those types. So this is an example of using both inheritance and method overriding when managing your network of different types of devices using Python.